So after getting or setting the needed data, in order to start our optimization problem, what we have to do is to define the variables. So what we will do now is to here define the variables. This is, we already finished it. So before doing that, let's quickly realize or just revise some data structures in Python. The first one is the list, and the list is we define it by having a square brackets. Now the list can be different types of datas. So we can put, for example, high and another 5, and for example m, which is a variable, but of course we have to define it. Let's say, I don't know what will be, like 1. So as you can see here, this is a list, and it is denoted by a square bracket. So we want to run this one. We can also, like for example, take the first element and assign other variables, for example hello, and then print the whole thing, the whole list. You can see that we removed high and assigned hello instead of it. Now the other type of data structure that we will use, and actually we used it here, you can see that the square brackets are the list and these small brackets are tuples. Now the tuple is, well, we can also put different types of variables, but tuple does not change. So once we assign it, we cannot reassign it. So for example, if we put the same thing, so like the whole thing, like high, 5 and m already defined, we can it can be accepted. However, if we did the same thing here, which is redefining the one of the elements, you can see that we are not allowed to do that, because tuple object does not support item assignment. So this is what we have in this. Another thing is, other than the tuple, is the dictionary, and dictionary are denoted by square brackets. For example, x3 equals, you will have these square brackets, and then like let's say 1000, and then let's say it has 0, and then high, and then it is related to, let's say, a value of 5. So what we have here is the key and a value. So the key is high and the value is 5. If we want to do print these statements, print or use x3, you denote x3, and then you write the key. In this case, it is 1000. And of course, you can even have the key as a string. So here high, and we can find that the 1000, the key is related to 0, and high is related to 5. Now last thing is, you remember we imported the collection library. So the collection library allows us to have similar to a string value, a dictionary value. However, what we can do is we can have one item, and it is related with multiple values. So for example, we will have, for like a point equals collection dot named tuple. Of course, collection has also other functionality, but this is the main functionality that we will use. You can have a name of the whole thing. In many cases we just point, but let's say but just to make sure you understand, it's not like 100, like we don't have to have the name of the of this point tuple to be related only with the name of the point, because later we will decide the name of the of this name tuple into the same as the name of the whole variable. So we can put any name we want, like points, whatever it is. Now we put comma, and here we have to be careful, because here every space it's kind of comma. So when we put x and then space y, that means the point is related to two arguments, or two variables, that is x and y. So when we want to assign the point, we have to put two arguments, that is x and y. So now we have point equal collection.named tuple and x and y. So that means we can now define a value that is related to two other values. And for that, let's assign one point. So pt, point, like we can say, we can name it anything, of course, we want. We call this as we call a function, and then we decide 1 and then -4. That is, the value of 1 is x, and the value of -4, sorry, is the y value. And then we can print the, let's say, the point and see what we have. Of course, we can also print the point.x and point.y. See what we get. So the point, when we print this point, we will have the name of the whole variable, and then x equals 1, y equals -4. But realize that the way we refer to it is pt, which is what we declared here. So the pt equals point, like this object, and pt equals point, and then we pass on these arguments to create this object. Another way we can, let's say, of course, we can create another point. For example, pt underscore 2 equals, and it's the same thing, point, and let's say 3, 5, and of course pt underscore 2, or of course we want to print this thing, or yeah, print pt underscore 2, and print pt underscore 2 dot x and pt underscore 2 dot y, and we can see that x equals 3, y equals 5. Now let's go back. So these are basically the data types that we are going to use, and for now let's try to, or let's define the variables that we need. The first thing is we need to set the model. The model, this is before we define the variables. Everything we will define is related to that model. This is very much a rule in the Google OR tools. So cp underscore model, this is what we already imported, dot cp model. So now everything will be attached to this model, and shift enter. Now we have no error, it's already got assigned. So the first thing is we need to do is we have to task type. We have to do the same what we did before. Now we said every task will have a start, end, and duration. So we need to define such thing, that is task type equals collections dot named tuple, and here we say task type. Now in this case we just call it the same thing, and we say here is we need start, end, and interval. So here we can see that we did the same as this one. So this is we gonna use. Another thing we will do is that we will use later, but we can assign it now. Assigned task type equals, well, the same thing basically, but we need to change. This is going to be the same name. Here we will have start and job ID, task ID or index, and duration. This is just to put our results into this variable. All tasks, we have a dictionary. We will assign one dictionary that will collect all the tasks that we have. This is the purpose of this dictionary, that later we will print these statements, and then machine to intervals will have another dictionary, and this dictionary will basically collect all the variables for every machine. We also need to create every like machine a list of every machine that we will put these variables into it. So the first thing what we will do is we will put the variables that is related to every machine in this list, and after that we will machine to interval, which is will be a dictionary that we will put all the variables into it, and it's all actually going to be related or indexed by the machine name or number, of course. Like yeah, we will see that, and we will print these variables, and it will be very more clear. Now for jobs or job ID, in like we will have and job. This is the same job in before what we did, so this is going to be the list, this kind of list, and job ID is just going to be assigned number, like whatever it is, like 0, 1, 2, 3 as the iteration goes. Now to do that we have to use enumerate jobs data, and the difference between enrange and enumerate is enumerate will give us the jobs data in this, the list will start this, we have 3 columns, 3 rows of these. So the first row will assign to here, and the job ID enumerate will give it the ID of 0, and then the second element will have 1, and the second element will have 2. So this is why it is useful. And here we also go for task ID and task, similar to what we did before, but now we use enumerate, and then we have the job, which is here. Now machine equals task 0, which is going to be the first element, which is this one, the name of the task, and then one, of course, going to be the duration. So this is the machine that we are going to use, as we said before. Duration is going to be task, and now is 1. Now, suffix is related with the syntax of the OR tools. So the thing is, in the OR tools, we have to define the variables with a suffix. That is, we have the variable basic name and the suffix related to that basic name, because we will, in many times, we have to create multiple or many variables. So this is why we have to add this one, underscore again I, and this way we have the suffix going to be underscore. Sorry, here we have to put I, and here another I, and these variables will going to be job ID and task ID. Now start variable equals model. This is always syntax. So model, what we defined before, model dot new integer variable, and it will start from, it has the value of 0 to horizon. This is the horizon we defined before, and the name of this going to be start plus this suffix. Yeah. Another one is going to be the end variable equals, well, it is the same thing, but we have to add end. So here we're defining the first variable is the start of the task, the start time, the end time, and now we define the interval variable, and it equals model dot. This has a little bit different, because interval will have a start, a duration, and end. So model new interval variable. This is all syntax. This is all syntax, and then what we will have here, we say it will have a start and a duration, which we took from here, and end value. It will also have, as before, the interval plus suffix. So here we define these values. Now what we have to do is, as we said before, we will add all the tasks that we will get from these into all tasks. So we get this one, and the indexing here will be 2 numbers. So job ID and task ID, and this will equal task type, so this one, and then we will say we have start, end, and interval. So there has a job ID, it has a task ID that we take from here from here, and this has to be so the job number, and is it going to be the first job to be done 0, second task to be done for that job will be 1, third task will be number 2, and so on. So this is the job ID, this is the task ID, and then the task type, it will have a start value, which we said here has to be equal the starting variable, and end value equals to end variable. Of course, you don't have to write start equals start variable, but I mean, it's more clear to have it like this. So start, end, and interval. Interval also will have interval variable, but we have to put interval equals this one. Now we need to populate these lists. So if machine equals 0, we will have machine underscore 0. We will append this interval, and we repeat these things for every machine. So machine 0, 1, and 2. Yep. So finally, what we will do is we need to, for machine, we need to assign all of these into the machine intervals. This dictionary, what we created before. So machine in all machines. Now all machines, again, this is we did before. We have it from 0, 1, 2, 3, this one. So just use this thing. If machine equals 0, just we take to machine, or you can just write it 0, and this will be this one, and we keep doing this for the other machines. So here 0. Of course, there's many other ways to do it, but because we don't have much machines, we can just do it like this way, and many times the number of machines are limited. So here is, this is just our variable declaration. Like here we can say what we have here, define the variables location. So we run it and see how it goes. I think there is name tuple. Just tuple, not tuple. So now it's running, and as we said, we want to see the machine intervals and other machine interval and all tasks. What we have, these are the most important variables that we have. Other variables are just going inside these. So machine intervals, we can see that machine 0 will have these intervals, which is the job 0, 1, and job 0, task 0, and job 1, task 0. And the other machine 1 and 2 will have 3 intervals because it will have job 0, 1, job 1, 2, task number 2, and job 2, task number 0. And we go through the whole thing. Now for all tasks, we can see also here, again, we go see the all tasks have job ID and task ID. So job ID is 0, task, the first task is 0, job 0, task 1, job 0, task 2, and the whole variables. So these are our variables, and next classes we will talk about how to assign the or how to set the constraints as well as the objective functions, and then solving and getting the results.